Good morning, everyone. I hope that you're doing well. I am using a different microphone today than I normally do. Let me change my camera on. So I haven't used this before in a stream, so if there's any latency or any volume issues, then let me know and I can adjust those. I tried having a bit of a play around with it this morning, but there's only so much that I can test without actually being in a stream. Also I apologize if you hear a cat crying. One of our cats is having a whinge. Cool, thank you for that confirmation, Dine. As you probably will have guessed from the thumbnail of this live stream, this is going to be an exciting one, but I want to put off the excitement for a little bit. I genuinely have not actually tried the throw sequence on Jugglebot before because I'm a little bit worried that it actually might break and require like several hours of reconstruction to put it all back together again, and I didn't want to have to do that before the stream and then be in the stream knowing that it's going to break. I want to share this moment with you all, be it good or bad. But before that, I want to just talk about what I changed from last week and what's new, and I don't know, sort of my feelings about how this is going to go. Because I have very mixed feelings about it, but we will get there when we get there. All right, so housekeeping from last week. You may remember that the way that I was handling the trajectories was terribly inefficient. I was basically regenerating them more times than I needed to, just doing like at least double the work compared to what I had to do. It's a little bit better now. What I've done is you basically just need to read this. If you're interested, you can read this comment block at the top and that just describes what's going on. Suffice to say that when we receive the current path and the next path, we just assume that we've already received the current path because that was the previous next path. And so we just ignore it and then just tack on the next path to our list of trajectories. It's such a hard word to say. This does have limitations though, insofar as we won't be able to update the current trajectory. For example, if we have feedback with where the ball actually is, there's going to be no way to compensate for that. The path is set before we've even reached this like segment of the move, which is obviously a little bit troublesome. But there's no way for me to get feedback from the ball anyway right now, so it doesn't really matter right now. And I expect there's a lot of, in the last like 2 weeks or so, I've had a lot of times where I've been writing some code and I'm like, I know for a fact this will have to change soon, but it will move me closer towards Jugglebot actually trying to throw and catch, and that's a big part of what I care about right now, is just seeing if the hardware can do what I want it to do. Yeah. And also this still has issues with expanding to infinity. So if I have too many points in the trajectories, then the whole part of the code that processes those trajectories into like the actual movements for the robot, that takes too long, and so we can't process all of those points before the system thinks that it's ready for a new path. And so that list just keeps growing and growing and growing. So I've had a bit of a play around with the right number of points to use in those trajectories, just to try to keep it under control, and it seems to be fine now. A big part of why it's fine now is, as you'll see in a sec, I've got it set up so that the hand will throw, catch, and then chill out in the bottom position for like a second or so, and that just gives it time to kind of catch up, which is fine for one ball, one hand. Like when you're doing one ball in one hand, there's nothing stopping you from just holding the ball forever before you decide to throw again. So that's fine, but if you have more balls than hands, then you really need to obey the balls and they set the timing for you. So this will obviously only work for now. I need to make things faster, basically. And the rotation issue is fixed. So you may remember that when I was getting the simulation to move around, it was doing all sorts of wacky things. It turns out I was just being a Muppet, and well, at least I think it's fixed. I was being a Muppet and I used the wrong axis. So I somehow just forgot that my default orientation is up. And so all angles, like when we're throwing, we're going to be throwing at, say, an angle like that. The angle that we care about is this angle in here. But what I was doing is I was measuring everything from the x-axis, because that's the axis that we normally use. I don't know. So I'd always have this angle, and obviously that's 90 plus the angle that I actually want, and so that's why everything was freaking out. So thankfully that was pretty easy to fix. And along the way, because I was really under the impression that these issues would be quaternion based, because I've been having mindfucks with quaternions in the last couple of weeks, and so I was really sure that it was there. And so what I did is I basically went through and changed everything, a lot of things, to be quaternion based instead of having to deal with Euler angles, which I'm sure some people will be very happy about. I'm not, because I still don't freaking understand them. They're so confusing. But yeah, it turns out this was the problem, and this was pretty easy to fix. And I want to say a big special thank you to Alice, who in the last video suggested changing, on the last live stream, suggested changing the way that I was setting up the states, and it makes so much more sense. So what I was doing before is I would have one type of state, was position, velocity, and time, and this is like the throw state. So if I'm going to throw from here, I'm going to throw from this position with, say, that velocity at a given time, and then when I catch, I'm going to be over here, catching in this position with like this velocity at some time later. And that's good, but for other parts of the code, I don't care about velocity, I care about orientation. And so I would have this sort of state, position, orientation, and time. And of course, if you've done like any physics, you'll know that velocity is just the orientation with a scalar, like multiplying how big the velocity is. But I wasn't too, I don't know, I just didn't make that connection or something. I don't know why I didn't think to do this, but Alice's suggestion was to swap things around. I don't know if they said exactly this, but something along these lines, to have position, orientation, velocity as a scalar, and then time. And this is very good because it allows me to be more consistent, as well as giving me useful information when I am kind of surprised that I need it. While I've been going through making all of this code, I've seen the like the docs for the ROS message types, and I've been very confused previously, not anymore, by how so many messages have this stamped property. So like this is a list of a bunch of the message types, and you'll see we've got like pose, so that will describe like the orientation of a thing, and a bunch of other things. But then we've also got like pose stamped down here, and we'll have point. I don't know why these aren't like alphabetic or anything, but we've got point stamped down here. And there's all these stamped ones, and I was like, why have they gone to a lot of effort to include stamping? And stamping, by the way, is includes two things that I have been largely ignoring up until now, to my massive detriment, which have been the time that the event is supposed to occur, or whatever time you want to encode with that event, as well as the reference frame that that event is in. I've been completely ignoring that, and that ties into the whole TF2 thing that I mentioned a little bit, but haven't implemented yet. But the time thing, I was a bit like, why do you care about the times so much? And I just kind of didn't think about it and ignored it, and yeah, just put it aside. But it's actually been super useful. And I've had to kind of like reconstruct what this message would tell me from only, like for example, if I have this message and I need velocity, I can get it by getting two of them and then taking the difference of the positions and the difference of the times and then constructing the velocity, which is actually what I've done in something that I'll show in a sec. But if I just had this message the whole time, I can just grab the velocity and I just have it already. I don't have to do any of this wacky extra business. Yeah, so this, I feel very good about changing over to this sort of structure, and depending on how the test today goes, I have a feeling that this is very close to, like very high on the list of things that I'm going to do soon, is change all of the states over to position, orientation, velocity scalar, and time. Very, very good idea. Thank you, Alice. And actually, while I'm thanking people, I think it was Fox FPV25, I can't remember what your name is, but your suggestion of the Colcon build symlink install thing has saved me so much sanity. So if anyone's used ROS before, you'll know that when you make edits to your code, you usually need to like rebuild the whole code. And for me, like I've just run one this morning and that took 30 seconds. And 30 seconds isn't a huge amount of time, but if you have to do that every single time you make any little change, you start thinking, I have 30 seconds right now, I can do something else. But then of course, by the time you've changed your thinking to that other thing, the 30 seconds is over and then you've got to change your thinking back. I think this is called like context switching and it just doesn't work. And yeah, that was driving me mad. But with this symlink install thing, you just save the file, close the, like destroy the ROS network or at least the node, bring it back up again, and it's all fine. It takes like 5 seconds versus 30 plus that extra 5. It's been a massive lifesaver. I am extremely thankful for you telling me about that. I really like it. Yeah, there's one more quick thing that I want to mention now. I have a feeling that more people are going to be viewing this stream than normal, and so I feel like this might be a useful time to mention this. I kind of maybe did a bit of damage to my Linux installation on the Jetson, which is the computer that's controlling Jugglebot, and I really don't know how to fix it, and I'd really appreciate if someone has any insight on what I could possibly do here, because I'm very, very not familiar with Linux, and I don't want to break anything more than I already have. So what I was trying to do was, right now, this is a little bit hard to show you right now, but I have a big, maybe I'll show you, yeah, no, it's a little bit tricky to show you, but I've got a really big screen in front of me and half of it is the Jugglebot computer and half of it is my like other computer that I'm doing all the streaming on and everything. And that it's kind of annoying to set it up so that I like change the screens over every single time I turn the Jugglebot computer on. It takes like 30 seconds to a minute every single time I turn it on, which isn't a huge amount of time, but it's a bit annoying. And so what I was trying to do is get it so that I can run the Jetson headless, so without a monitor, accessing it virtually through my personal computer. And yeah, that way I wouldn't have to do any of this like switching around the screens or anything. And so I found No Machine, which is apparently really good and like has super low latency and everything. But of course, it doesn't have as low latency as just having a monitor by default. And so I decided I didn't want to use it anymore, so I uninstalled it. I followed all the steps at this link here. Yeah, I was unimpressed by the latency and like having the bar at the top really just like eats into the monitor space, even though I can't really complain about that, I suppose. But it was a bit annoying. I tried uninstalling everything, but I couldn't undo everything. And so now I have a startup script that runs this line, which anyone who knows Linux is probably thinking, what the heck have you done? Even ChatGPT told me, this approach is somewhat unconventional, I'll get rid of myself, and bypasses the standard management of display managers, which could lead to unexpected behavior. It's primarily a temporary fix rather than a long-term solution. I don't know what the long-term solution is. I don't know how to troubleshoot this. All I know is if I don't have that code, then if I don't have this startup script, then nothing displays on the monitor and I have to go into the Jetson with SSH and then run this to get it to work. That was a very frustrating couple of hours. Anyway, yeah, if you have any thoughts on that, then please let me know. Actually, other weird symptoms as well, just in case this helps troubleshooting this. When I boot up, the screen flickers heaps, and if I have any windows over icons on the desktop, it like flickers and like really spazzes out. And it also seems to be running a lot more slowly than before, which maybe is just in my head and I'm telling myself that it's running more slowly to kind of make myself think that my code is not as slow as it actually is. I don't know. It's really kind of annoying. But at least it kind of works. Anyway. Yes, a big step forward for the project, so leaving all the other nonsense behind, this is actually progress. Jugglebot Sim now has a ball, which may seem trivial, but I think is actually very important. If you want to check this out, the code is on GitHub, which is in the link to this, in the description of this live stream. The node is called Ball Manager Node. And the reason why this is important is because the ball, especially for one hand or for any number of ball juggling, the balls are the only thing that has contact with reality. These are the only things that actually dictate what has to happen and when. Without the balls, the robot's just sitting there waiting and it's just doing nothing. And so we need to obey the balls and yeah, do what they tell us to do. This may sound weird, but it makes a lot of sense. And I have a feeling this is an idea that's going to be more and more important as we move forward. So the question is, how do we obey the balls? So what I have set up now is if the ball is being held and the velocity of the hand is less than, so let me start together. If the ball is being held and the velocity of the hand is greater than the velocity of the ball, then that means that the hand is still pushing the ball forward. I'm assuming that there is a perfect hold here so that it will never just like slide out the side or something like that. But making that assumption, which I mean, we'll see how valid it is soon, then as soon as the hand's velocity becomes lower than the ball's velocity, then the ball has been thrown. And then it continues following its normal projectile motion and it will land wherever it lands. And then to catch, if we later have the ball at a position that is at or near, with some tolerance, the hand, maybe with a similar velocity, maybe we can add that requirement, then we can say that it's been caught. I haven't actually implemented this yet, and you'll see why very, very soon. But that's the idea with catching, is that if we're near the right spot, then at the right time with the right velocity, then we can consider that a catch and it's worked. And if not, then the ball has been dropped and yeah, it wasn't a successful catch. So, enough talking. Let's see it already. I want to show you the simulation first, just because, yeah, I'm very unsure of what's going to actually happen with the robot, but let's have a look at the simulation. So let's go to here. I've also got a new camera, which is very exciting. Let me turn that one around, actually. Yeah. Really doesn't want to go. All right, let's do the simulation first so we can get rid of these. So I will start things up. We can get rid of that, make that big. Cool. All right, so we can see we've got our ball in the middle here. It is alive and ready. And here's the robot. And so the way that it works, let's get rid of all these messages. If I am moving, I can throw the ball. But a problem here is that as soon as the hand velocity becomes larger than the ball, as soon as the ball velocity becomes larger than the hand velocity, it considers itself thrown. And especially when I'm controlling it with the space mouse, there can be instances where I might be speeding up, and then I'll drop in speed just for a smidgen and then continue speeding up again. And that little tiny drop is considered a throw. I should add some sort of filter in here or like a smoothing algorithm or something, but that feels like it will slow things down even more. And to be honest, I only did this yesterday, so it's still very new. But it kind of works, and you can see it really launches the ball. So that's with space mouse control, but then we can also go on juggling control. And we can see, look at those beautiful lines. Let's get rid of the ball for a second. We can talk about that in a sec. But yeah, this is what it's supposed to look like. All the paths are looking nice. There is a weird overlap here. Like this shouldn't be overlapping like this. I don't really know why that's happening. I think I'm not clearing paths correctly. I don't know. It's a bit weird. But actually, let's bring the ball back. Yeah, so this is supposed to have a throw height of 100 millimeters, but we can see if I bring the speed back, let's wait for that to stop, the maximum velocity that we got for the hand and the ball is like 7.5 meters per second. Oh, this is a bit small for you guys, isn't it? Zoom in a bit. Hopefully you can read that. If not, you just have to take my word. Yeah, for some reason, the velocity is way higher than it's supposed to be. So this is the part where I was talking about how I'm calculating the velocity based on the difference of the two positions. And I think this is causing this issue. To cut a long story short, the way that this is constructing the path, part of the way that this is constructing the path involves placing the points along the path so that the velocity is what I want it to be. And because at the tips of this path, the hand needs to be moving faster than at the bottom to actually throw and catch, those points are further spaced apart. And I think that they are so spaced apart at the very, very extremities that it's making this velocity seem much, much higher than it actually is. This would be solved if I took Alice's suggestion on board sooner and had done a sensible state structure, but I haven't done that yet. So I think that that's causing that problem. And we can see if I show you the GUI or the thing, the ball seems to disappear. As soon as we throw it, boom, it's gone. Where the heck did the ball go? And I was a bit confused by this, and to give you the clues and see if you can figure it out for yourself if you're interested, what I'm doing here is comparing the velocities, as I said, and that happens in as close to real time as I can get. And then, as soon as the ball is thrown, the way that we figure out where the ball is based on the real, actual current time. And that, to me, seemed correct in theory, but there is a bit of a delay between the Jugglebot, like me giving the positions of where the hand needs to be, and then the hand actually being there. There's a bit of a delay there, even in the simulation. And that means that as soon as the ball has been thrown, it compares its flight path to the actual real time, which is like 1/3 of a second later than the simulation time. And so what happens is the ball disappears and reappears all the way up there. It just gets yeeted way out. And yeah, so that's obviously a bit more than a 100mm throw. And yep. Yep. So I'm not expecting this to happen in reality. This is obviously not going to happen in reality because the hand is only going to be moving as fast as these 3 orange dots are, which is not nearly enough to throw the ball, whatever that is, like 5 or 6 meters up. Yeah. This is part of why I'm a little bit unsure of what's actually going to happen with the robot. So, my thinking right now, we have 2 options. This is about as much as I wanted to show you on the simulation. So, I'm pretty ready to try it on the robot, but I'm unsure of if it's worth trying the path like this, or we can make it so that the catch and throw position is just straight up and down. And although, just as a little, I don't know, mention here, this looks like it is actually catching and throwing, like the ball is like, wow, it lands right in the hand just before it throws again. That's actually not what's going on. You may have noticed with when it was throwing like off to the side a bit, the ball just disappears after a bit and then magically reappears back in the hand. And that's because I've set it up so that if the ball is in flight for more than 1.5 seconds, then I'm going to assume that it's been dropped and then just put it back in the hand. And that's because 1.5 seconds is like, it's a fairly high throw. It's like a more than 1 meter throw height. And Jugglebot is not going to be doing that right now. So I think that's a valid assumption. Yeah, so I'm unsure if it's worth trying an angled throw like this or a straight up and down throw. Part of me wants to do the angled one just because it's a lot more satisfying. Like a straight up and down is a bit lame. Yeah, I've got nothing else to say about that. Let's just do an angled one. All right. So I need to restart my ROS network with the CAN bus node active. Unfortunately, when you're changing the launch file, I've found that you do need to rerun the Qualcomm build, even though I've got the Symlink install thing on, which is a little bit annoying, but I'm happy to wait 30 seconds every time I have to do that, rather than 30 seconds every time I have to do any change. And yes, also I am aware that I can do the Qualcomm build for a specific package. I should be doing that, but I'm not, because I'm a fool. All right, once this is done, we can probably turn the robot on. Let's get yeah, so this is actually the other thing. Maybe while that's going, I can show you this. I got this fancy new camera, which is very cool because I can move it around. So it's currently on Jugglebot, but I can pan it around and it will also track me. So if I'm in the shot, I should be able to do this. And now I can move around and it will follow me around. How cool is that? Now I can come back here. Where's a good spot? And then it will stay. So good. Yeah, alright, so that's run. We're good to go. So we can power it on. It nicely, everything boots up to be, to all extend. I'm actually going to add me as well in this shot. I've only just very recently gotten this camera and I haven't set up all my views properly. But let's add me in here too. So you can see my beautiful face. And my consternation when it fails. Alright. Yep. So I'm running the ROS network, starting it up. Heartbeat has been received. Let's refresh the GUI. It's really tricky. I would like to show you guys everything. Like I've got this. Where is it? Oh, it's here, but I've hidden it. I've got this view. I don't know. What do you guys want to see? Do you want to see the GUI or do you want to just see the robot? Or both? Or we can do this with the GUI in the corner. Oh, that's the wrong one. Money shot. Robot only. Alright, not even my face. Small GUI, small GUI. Let's put that up there. Oh, it's a bit too small to really see anything though. Face, yeah. Alright, I'll get rid of this. Alright, so we can home. And in case you're wondering, I've got my e-stop right here, ready to go, just in case. Yeah, I feel like I've really taken the lead from, I've been listening to a lot of podcasts with Boston Dynamics people, and they've been saying repeatedly that you need to be prepared, you need to be, I don't know, able to have things fail, and you need to be able to test things until they fail, and if they do fail, then that provides a useful learning experience, and that's what I'm hoping this will be, even if it does fail. So this is not throwing yet. I just want to make sure, so the throwing will be in side to side, which is perfect, that's so good. I was worried I would have to turn the robot to get it to be in the shot properly, but this looks good. Let's raise it up a bit. Alright, I'll give it its ball. And actually I should have checked this before, because when it goes to juggle, it starts really low. So I might actually just jog it down quite low. Alright, I'm just gonna do it, you know? Oh, that's so slow. What the heck? At least it doesn't break. I mean, that's good. Yeah, alright, so let me show you the GUI as well. I'm very glad that that didn't break. Let me bring in this one. So you can see, yeah, it's going a lot slower than it is in here. That could be because I reckon we can change this at risk of breaking things, but you know, I just said that that's fine. So let's stop that for now. So I have set the speeds to not be super high for the motors, but or you can turn the limits off. I'm not gonna. There is no off. There's only a number that I can tell the motors how fast to go. Where do I set this? It's been a little while since I've changed this. So, alright, give me a sec. I need to change some things around. So right now in the GUI here, let's bring back the proper GUI mode. We've got all of these messages in here that's clogging up my feed, so I can't see anything. And this is just like debugging that I was doing yesterday. So I will turn these off. And yeah, let's leave them off. And see if I can find where I changed the speeds. That's weird, they're already set quite high. I actually want to try it without having done the space mouse first, because when I do the space mouse, I set the speeds to be really low so that I don't wreck it with the space mouse, because the first couple times that I ran it with the space mouse on, let me just put me on. The first couple times I ran it with the space mouse on, it just completely shut itself. And so I've been making it lower the speeds a lot. Yeah, let's see how it goes when I have that all turned off. So let's end the session and close the ROS network. Bring it back up again. Thanks to Symlink install. Woo, so fast. Heartbeat received. Gotta refresh this. That's interesting. All right, what should we go on? Let's go on Jugglebot view. I need to turn this off again. I haven't got it set up so that I can close the ROS network and reopen it while the robot is still on. I have to turn the robot off and the ROS network off and then start them both up again. I should probably fix that, but to be honest, I haven't had too many instances where I've had to do that so far. Let's turn it back on. And we should be able to see in the GUI, it will tell us what speeds things are set to. Why aren't you homing? There we go. Oh. So we've got, there it is. There's the culprit. I just need to find trap charge limit set to 10. 10. So slow. I want 10. For context, when I was testing just these linear actuators by themselves in the last video, well, the video a while ago when I did the linear actuators, I think the max speed I got was like 50 something. So this is 1/5 of the speed that a single actuator can go at, which is probably not the speed that it can go at when it's actually on the robot because there's all the inertia of the platform and everything. But it should be able to go a lot faster than 10. So where is that? CAN bus handler node. Trap. Let's see what I'm doing. Yeah, see what I'm doing. Where is it? Let's just do it on here. What? Yeah, so we're in CAN bus handler node. We've got to find trap. Traj. Nope, that's coming from CAN handler. Trap charge limit set. Ah, there it is. 10. 50? 50 acceleration limit. I can't remember what the limit was for this. Let's go 20. So it doesn't accelerate too fast. but after it does accelerate, it should be able to be going quite fast. All right, this should be a absolute shitload faster than what it just was. To the point of probably breaking. That's cool, okay. All right. Let's go back to robot view. Get rid of this. Restart the rollers network. Restart the GUI. Home. Home should be the same as before. Okay, and we have our trap traj limit set to 50 and acceleration to 20. Send it. Ball is in. Oh, I actually want to jog it back down as well. All right. Nothing happened. Why did nothing happen? All right, this did happen sometimes, and I need to restart the GUI. So let's, nope. Oh, still too slow. All right, let's go faster acceleration. Much faster acceleration. Granted as well, this is also only set to do a 100mm throw, which is very low. That's like that high. It's only very small, so it'd still only be little. But yeah, let's put that acceleration up to like 100. And start rolls again. Restart this. All right. Whoa, that was fast. All right, and jog it back down. That is a lot faster than before. That's like instantly moving as soon as I click. All right, let's go. Oh! Ah! Stop! All right. All right, I think that was all right. Let me move the camera down so you can see the the result. Thankfully, all of these joints are magnetic, and it didn't look like any of the it didn't look like any of the strings broke. I think. We will see in just a second. And for better or worse, I've gotten very used to fixing it when this happens. Let me just turn it all off because it's going to be easy to fix. What the heck has happened here? It's all gotten tangled up. One of the legs has completely come out of the base. All right, maybe we should try just a straight up and down throw after this, if it still works. Yeah, these are pretty easy to snap back in. Oh, whoops, I missed one. Whoops. I've been dreaming of having like a robot arm mounted to the roof so that I can like put cameras and stuff on it, and also to hold this up because this is so freaking hard to hold when I'm putting it all back together. What has happened here? That one goes to there. That one goes to there. Okay, I think they're all still alive. All right, I think we're good. Oh, we've bumped off some of the boxes. Okay, let's try again. Boot it up. You think you saw a catch? If you've looked at my YouTube channel at all, you will have seen like on the banner, I've got all the goals, and I'd be very, very happy if we can tick off the has caught a ball. So maybe it's worth going back and like, I'll have to like review the footage or something. Or if anyone can like go back and if you can verify that there actually was a genuine throw and catch, we'll see. But let's try a straight up and down throw. I think that's going to be a lot less likely to break things. Alright, so I'll change that in the GUI because I don't want to risk it not actually updating properly. So that could be 0. Yeah, it all seems fine. It's all booted up again, so it's. I think we're good. All right, hang on. I think my cat wants to come in. Come on, Albie. You can join the fun. Actually, there's a funny thing. This camera has animal tracking mode, so let's see how well it works while I'm getting everything ready again. Oh, this is great. What do you want, Albie? I'm busy. Oh, that cable's in the way. Oh my god, he is so dirty. He's just been rolling in the dirt for the last, like, 20 minutes. Come on. You can join me up here. Oh, that's not a very nice view, is it? Let's put it back on Jugglebot. Other way. I wonder if Jugglebot would count as an animal. Alright. I think we are good to try again. God damn, you're dirty, Albie. Get out of here. Albie can watch the juggle. We need the ball back. Albie, shut up. Let's start the... Where did that go? Start the rolls network. Actually, this is interesting. I want to, just before I restart things, look at the CAN bus. I guess that's because I've got it set to stop. It like goes, stops, chills out for a second, and then goes again. That's cool. I like that. I really like this like traffic monitor thing. It's very handy. Stop it, Albie. All right. So we can restart the GUI. Home. Oh, that's not good. We're getting overspeed errors. Let's just clear them. Feels a bit wrong just having an option to just like remove the errors. That is weird. I don't know why that happened. Let's just turn everything off, let it cool down for a second, and then turn it all back up on again. Let me just double check that things seem fine. It's possible as well. So you may remember that I was having issues with some of the encoders, and because of the way that these actuators have the encoders in the base of the actuator, it's like in here. So sometimes when they fall over, as they just did, the encoders get bumped a little bit and they become misaligned from the motor. And that's kind of annoying to fix. Oh, this is probably not good. It's not even on there properly. Let me just check all those. And it looks like no wires came out. So I think we're fine now. What are you doing? Stop sniffing my strings. God, it was a long time to get the strings in like tight enough that the cats would leave them alone. But thankfully there's nothing loose anymore. All right, let's try that again. So powering on. This should all move up a little bit. That's good. That suggests to me that the encoders are fine, because it would freak out during that boot up process if the encoders were really cooked. So they're not that bad at least. Alright, reboot the GUI. And let's try homing again. That one is freaking out. Alright. That was motive 1. I love the e-stop with the just fucking whack it. So motor 1, which one is that? This one. Oh, the encoder wire had pulled out a bit. Let's just check all of them. Yeah, I don't know if I really vibe this design with the encoders in the actuator for this purpose anymore because of this bumping business. Yeah, I'm getting every time I think about it, I'm more and more keen on the idea of a cable robot. It just seems so much simpler. And to be honest, I feel like it is the obvious structure for a juggling robot. It's just that I didn't know what I was doing when I committed to this. Alright, let's see if that helped. Power on. All are booting up. Start ROS. Boom, boom, boom. Start the GUI. And home. No, it's going out. All right, we can fix this. We can fix this in real time. You're just gonna have to give me a second. If you want to grab a coffee or something, you can grab a coffee. It's gonna be a second, but not too long. It'll be if the problem is what I think it is, it'll be 5 minutes. But we do need to get some cables. So what I've had to do before when this has happened is re-flash the firmware to the O drive controller. And then rerun the encoder search thing, whatever that's called. I am committed to having at least one more throw attempt. Because nothing's actually, as far as I can tell, nothing's actually broken yet. So it's good. Get in there. So I just need to, annoyingly, you can't change any of the internal settings in the O drives with over CAN. You have to actually use the USB interface, which is a little bit annoying, but that's okay. Didn't quite throw. Oh. Yeah, I don't know if I'll count that. Thank you for checking back, Derek. I appreciate that. I reckon for the next one we just go ham. We just set the throw height to be super high, just commit, and maybe have a small. I feel like it's kind of cheating if it throws just straight up and then it catches by the ball just kind of being straight up and down. I feel like that's kind of cheating. I feel like for me a catch would be on some angle, an actual juggling throw. You can't juggle two balls in one hand if you're throwing them straight up and down. It just doesn't. In the same line, at least. It just doesn't work. So if you want to see what I'm doing, we can go into O drive tool. And no, let's just do the whole thing. I've tried a bunch of things here and I feel like what I'm about to do is a little bit overkill, but it's the only thing that I've found that has worked reliably. Let me just bring this in properly. Baby steps, definitely. Definitely baby steps. That's more of a throw and a catch than it's ever had before. So I guess that counts for something. Alright. So I need to remember where I put the firmware thing. Jugglebot. To go back one. And we can O-drive tool, DFU. Let me just double check what the actual command is, because I don't remember. No, it's not DFU. It's really weird. I don't know why I need to do this restore config thing, but it works. I don't know what else would, like I don't know what in the config would change as a result of it like freaking out. But for some reason this has to be done. Alright, so we've restored the config and now we need to go into O-drive tool. Thankfully these are O-drives 0 and 1, so I don't need to change the CAN. Yeah, I don't need to change the CAN node IDs, which is good. And let's see, I wrote this in the last, in one of the old PowerPoints. Oh no, I've got the commands here. All right, so we need to go O-drive. See, this is the other thing as well. It's the Jetson is a lot slower after this whole like no machine thing that I was talking about before. And I don't know why. I have a feeling it has to do with like the graphical interface is just like not rendering properly and it's like conflicting with something else and just kind of slowing itself down. Yeah. What do we need? We need config. Where are we? These two. Access 0, encoder, config picker related. We need to turn this to false. And then the same thing for the motor. And then we can run the index search thing. So this is access 0. And if you want to see what this does, this basically will make the leg go longer and shorter. This is what I was doing previously every single time I turned the thing on, which is very tedious. But it will basically run a little bit until it finds the index of the encoder and then run through one full revolution in each direction. And then it's happy. So I can put that back. And now we can do the same thing with the other one, but we can set these to be true now. Now we can do the other one. Yeah, if you're seeing this lag, that lag exists for me as well, and I don't like it one bit. It makes typing very tricky. And like the cursor display just like disappears sometimes. It's like it flashes for a bit and then it's just gone. I'm like, where the fuck is my cursor? And now Abby wants to get out. All right. He's bored. He's had enough. Get out of here. False, false. We need to do the requested state. So this is the motor that was freaking out. So hopefully this runs fine. And if it does, I feel good that we should be fine, unless one of the other motors also needs this to be done. Which, I mean, it's not too bad. Like, that's done now. So we can save. Oh no, we need to set those to be true first. And motor. Did that actually work? And actually, while we're here, it's probably worth checking that the can baud rate is correct, because I have changed that from the default. What is that? 1 megabit? That sounds correct. Yeah. Yeah. So we've got in can handler, bitrate is 1 million. Cool. All right, so we can save that. Cool. Okay. Let's try this again. Okay. So we can, let's kind of put this in a more happy position. I have noticed, so the way that the homing works is the motors, the actuators will shrink until the current has become larger than what the limit that I've set is. But I've noticed that sometimes if the platform is in a really weird position, if one or two actuators are particularly long, then they will hit that current before they've actually hit the end. I think because they have to kind of like overcome the inertia of the platform moving from a weird state across back to its normal state. So it has to exert a bit more force than it otherwise would. So it has to be kind of okay for the homing to work. All right. So let's just turn it off, make sure all the errors are gone. Let it chill out for a sec, just for good measure. Turn it back on, should all raise up a little bit. I think I saw one of the actuators not move then. The one, oh, I guess I can't really point it out. Yeah, we'll see what happens. All right, the GUI seems fine now. Let's try homing. No. I don't know what that is. On axis 4. Spin out detector. Okay. All right, so I'm going to do the same thing again on axes 3 and 4. So we can unplug USB. This one. I don't know, 4 and 5 is the pair. And this is giving you a little bit of a glimpse into what life is like developing Jugglebot. Lots of time on my knees, plugging stuff in, unplugging stuff, scratching my head, pulling my hair out, all the usual things that people do for fun. Alright, let's go back to this. Where is it, that one? Alright, let's do the same thing. Overdrive tool, restore config. And now we will need to change the can nodes to 4 and 5. So maybe let's do that now before I forget. I need to bring my notes back up. Let's see, overdrive 0, can config. Where do we change? Ah, damn, I stopped taking notes on the overdrive tool before I got into CAN bus. Would someone be able to look up what the command is for that? I need the change CAN bus overdrive node ID And in the meantime, I will continue with the rest of it. All the stuff we did before. So we need to set the axis. Sure, let's do axis 1 first. False. Yeah, this feels like a bit weird that this works the way that it works, but it has worked in the past, so let's see if it works this time. Let's turn them all off now. Huh. Oh. Alright, and now we can do drive 0. What is it? Requested state. Axis 0 requested state. So many goddamn commands you just got to memorize. Alright, so this is axis 0, so this will be 4, which is this one here. Yeah, you may be wondering why I've been like coming over and holding them before running this. And that's because if I don't, sometimes it freaks out. If there's like too much force that it has to push against, it doesn't seem to like that very much. So I prefer to do them just individually by themselves. Alright, so this is the one that was causing the problems a second ago. And that just ran fine. So I think we're good. And now we can do the same thing with axis 1. Cool, that looks fine. And now set all the things to be true. God, it's so slow. Why is it so slow? This is axis 1 motor. Axis 1 encoder. Axis 0 encoder. Axis 0 motor. Hopefully we don't have to do this with the other O drive as well. True, 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 true. Alright, I need the can thing. What is that? I swear I'm like missing a... Ah, it's this one. That's not... I've got a... I have a few too many... Ah, there it is. Alright, I've got it. I've got a few too many windows open, I think. Can protocol. So this is what I need. On here, we can see the command config. It's just can node ID. Of course it is. O drive 0, axis 0, config. It's literally right there. Yeah, see right now it's probably 0. Yeah, I need it to be 0 will be 4 and 1 will be 5. If I don't do these, then what will happen is, I actually haven't tried this before, but what I think will happen is there'll be 2 or more, or I guess 2 O drives that are numbered 0 and 2 O drives that are numbered 1, and they'll both be trying to send messages to the CAN bus, both of them claiming to be the same thing, but evidently not being because their messages will be slightly different, and also the same thing wouldn't send the message twice. And so the CAN bus would probably crash in some form. I don't really know what the symptom of that would be, but it wouldn't work in any event. So now we can save. Cool. Okay, all right, let's try this again. Quit that, go back to that. Shut everything down just for good measure. Bring it back up. I think we might need to do this with one more, because that the same one that didn't move before also didn't move that time, as far as I saw. Alright, let's run the roles network. Just move my windows a bit. Okay. Alright. Restart the GUI. And let's see if we can home. Let's actually fix this up a bit. And put the lid back on here. Alright, now let's try again. Oops, shit. Okay. Alright. Nothing freaked out then, but I'm getting a warning saying that the robot is not homed, even though it is. So I think it's probably worth just checking. Sometimes there are errors in the sometimes there are errors on the O drives that don't show up in my GUI, which is a bit annoying. What is the command? Dump errors, isn't it? Alright, so this one's got no errors. Let's try. I think the troublesome one is for motors 2 and 3. So let's check that one. Yeah, it'd be very nice if I had like a desk of some sort that was big enough to have this robot on it. So I didn't have to spend so much time kneeling down and standing back up again. My poor knees. Getting old. Ooh, that's because I did the wrong one. Still no errors. Alright, I want to see if we can run this through. What one do I want? 4? 2. Which would be 0. I want to see if I can make axis 0 go through its index search thing, because that's the one that wasn't moving before, and I have a feeling something's going a bit weird with it. Let's try one. It's going now. Alright, that seems to have run without issues. Yeah, I think just for good measure, I'm going to go through the whole restore config thing with this one as well, just to make sure there's, I don't know, they're all kind of reset. It'd be great if I didn't have to do this, but this is the only way I've found that works. Okay. So we have O drive 0, axis 0, motor is false, encoder is false, axis 1 encoder is false, axis 1 motor is false. Alright, so they're all ready to go. And now we can run them through their sequence. first one. And if you want to watch me on the last one, just for fun. Keep it interesting, you know. Alright. And now we need to do the can IDs. What's the command? Drive 0. No. Config can. So axis 0 is 2. And axis 1 is 3. And now we can save. That's weird. Normally after doing the save, it will like disconnect the O drive and then reconnect it. And then it usually goes through its like little boot up movement, but they didn't that time. So that's a bit odd. Invalid state. Invalid state. What is that? Let's have a look. Invalid state. Invalid state was requested. Did I not set things? Ah, I didn't set that to be true. That was the problem. Alright. Hopefully that was the problem. At least. If it wasn't that, I don't know what it was. So what are they set to now? Let's check the can nodes just to make sure that they saved. There should be 3. Yes, nice. And what are these? These are false. Okay. Let's run them through the... I think that they will... So my understanding of what I'm actually doing here is that the O drives have the ability to remember where the index pulse is with respect to like all of the sort of magnetic fields in the motor. And then by what I'm doing right now, like what this process is basically saving where that index pulse is with respect to those motor currents, I think. And so I think because I set it to be false, so that it's not pre-calibrated, that like search index thing that I just ran where they go out and then back, I think that would have just completely forgotten about it when the O drive turned off. So I think I have to run them again. I think I will, just for good measure anyway. And then we'll set them to be true, and then we should be ready to go. So this is 0, which is this one. Alright, that's the first one. I've got to say, I do like these magnets. They're cool. I really like having the magnet joints. Someone suggested an idea a little while ago to have, like, if I show you a zoomed in view, keep going, come on. So these are the magnets I'm talking about on here. I can just like separate them. They're quite strong. I have to really like kind of push them off in a weird direction to get them to separate. Like I can't just pull these apart like that. But someone was suggesting having some sort of like a string or something connecting these two so that if these do fall, it can only fall so far before, like, so it doesn't like collapse to the ground. And I do think that's a good idea, but the main reason why I haven't done that yet is because I'm a little bit worried that that might actually make the falling worse, because it might get tangled up in itself and then just kind of like collapse. Because it is possible, especially when these actuators are out, it's possible that they can get like torqued in ways that will break something that's not the string. Like the string I can fix, it's a little bit annoying, it takes a couple hours, but it's fixable, and that's what I suspect will break first if we really push this to the limits, which I want to after we've done this. But if something else breaks, like the carbon fiber tubes, or I don't know, something else. I guess a printed part breaking will probably be the best, because then I can just print it again. But yeah, I don't really want to break carbon fiber tubes, because I don't have very many extras, I think. So let's do axis 1. There's this one. Back down you go. All right, and now let's make sure we tell it that it has been calibrated. Come on. Why are you so slow? I think VNC has also made this slower again. So what, like when I'm showing you through here, this is through VNC to the Jetson computer. And I think that's making it even worse, but there is still a fair bit of lag on here when I'm not VNCing into it. And I'm pretty sure that's because of the whole, no machine thing that I talked about before. Axis 0. Alright, true. Axis 1 motor, axis 1 encoder. Yep. Cool, now we can save. And hopefully this time we see those two actuators get a bit longer. Yeah, I think the one that I saw not moving, I think it's only not moving because its index is like right at the base, just by coincidence. So I think that's why it wasn't moving, because that's what it was doing before when it was going through the calibration sequence. Okay, now let's turn everything off, let it settle, and turn it back on again. That is probably overkill, but there's no kill like overkill. Alright, let's shut down ROS, which I probably should have done before. Launch ROS. Reload the GUI. All right, let's home. Cool, we're back. Woo! All right, let's try Space Mouse control. This is going to be super high acceleration, so I need to be very careful with it. I wonder if I can just like, does that count as a throw? No, I'm not counting that. That's silly. All right, and I want this to be as. I want to commit. No, it's got to be a cache the Jugglebot controls, not me doing it with Space Mouse. I would pick up the Space Mouse and show you right now, but honestly, with this high acceleration, like, I'm literally just like tapping the Space Mouse puck as like lightly as I can, and this is how fast it's moving. That is crazy. All right. Yeah, I want this to run as fast as it can, so I'm going to turn off all of the messages that I don't need. And velocity, ball velocity, where are you? So what I mean by that is, you can see my GUI got all this shit that's tracking the ball, and this was just like debugging from yesterday, so I don't really need that on here right now. Where am I sending that message? Here. turn you off. All right, let's end the session. It should go down slowly. Yeah, okay, cool. So we definitely know the hardware is capable of it, I guess. Is good. We just need the software and the hardware to be able to talk. All right, so that message is gone. The acceleration is still 100. What should we set the throw height? Let's just set the throw height to like, I don't know, 300 millimeters? That should be, that's definitely high enough to be a throw. 300. 300 is a good number. It's gonna be good. So much faster than it was before. Where is this? Here. 300. All right. And turn the robot off. I actually am going to note that down because I want to not have to do this every single time. So I want it to be so that I can restart ROS without having to restart the robot. Cool, okay. Now, let's turn it back on. Cool, let's just help it a little bit. And start ROS. Restart the GUI. Home. Alright, our throw height is set to 300 millimeters. Oh, we want that to be more than 0. I'm just going to double check that that's actually updating. So I believe I've set it so my recollection is that I've set it so that anytime I change these values in this pattern control box, it should resend those immediately to the ROS network. But I want to make, I want to make sure that these are actually updated correctly before we try juggling, because I'm not really expecting this to survive more than one throw. And in hindsight, actually, yeah, no, not in hindsight. In current sight, I want to change it. Let's close this down just before we try this. I know I'm being a bit of a tease right now, but it's for good measure. Because the biggest thing I'm worried about, this thing could shit itself completely, and the same sort of thing could happen as what happened before, and that's fine. But what you might not have seen, because it was all on the floor and the camera wasn't pointed down, is that the actuators still keep moving, because it tries to follow the pattern that's happening in the GUI, which is that like it will throw, it will stop, it will wait a second to a second and a half, depending on how far behind it is, and then it will try again. And it's that trying again that I don't really want to break things, because once the actuators have fallen down, who knows where they will end up, and they might just like yeet out and, I don't know, punch one of the electronics boxes or the wall or something. So I'm actually going to set it so that it will only ever do one throw. It's not very nice. Full screen, is it? So, just bear with me one more second, and then we'll have our next attempt. There was something else I wanted to change though. In the GUI, I want to change the X position. Let's go with 30. So the value that I just changed is like how far away from the midline are we going to set the throw and the catch? Because again, I don't want straight up and down is lame. So we want juggling path creator to hand state manager. Where do I do this? This is another thing. Okay, so I was meaning to mention this during like the PowerPoint part of the stream, but if anyone's had a look through my code at all, you might be very confused. Or, I don't know. If you've done any of this sort of coding yourself, you might have done the same sort of thing, but I really need to clean everything up. I've got so many stupid unit conversions where there really shouldn't be any. It's like, oh yeah, this like receiving the values seems like a good time to do a unit conversion, and there's all sorts of like random unit conversions in stupid spots, like millimeters to meters, nanoseconds to seconds. I really need to just like cleanse it, be consistent, and that would save so much of my troubleshooting time. So where am I getting it to wait? I don't remember. Yeah, and all this stuff. Like I shouldn't have, this is like old code. I need to get rid of this. Ah, here you go. Set a timer to wait before clearing the buffer. Okay, let's just make that like 2,000 seconds. 20,000. What is that? 20,000 seconds. That's a super long time, isn't it? All right, cool. So I have 5 hours after the first catch, first throw attempt to stop everything. That should be enough time. All right. And my camera only has 10% battery, so we just plug that in. That's the other cool thing about this camera that's doing this feed, is that it's all, well, currently it's just being powered off of its own internal battery. But it can do PoE, which is amazing if I had the right cables for it, which I think I do, but they don't really seem to be working. All right, cool. I think we're good now. Okay. Goodness gracious. All right, so ROS is stopped. Robot is on. Let's give it a go. It's home. Robot not homed. Oh, why you do this? We're getting that same error from before. Robot not homed. Home robot. Let's just turn it off and turn it back on and see if that helps. You know, the old reboot. Sometimes does the trick. Everything seems to have moved then. Maybe let's move the camera up a bit. So you should be able to see all the chaos that goes on the floor, as well as the ball being thrown. All right, let's home again. All right, seems happy now. Jog it down. YOLO, I guess. Well, it didn't break, So that's something. I just missed it in the YouTube preview. I didn't really see what actually happened then. Let's go a higher throw. So let's end the session. Yeah, I really need, I need to figure out some faster way to go from the pose that I want the hand to be at to the robot actually, to like the leg lengths that will put the hand in that position. And this is another thing, this is another reason why I'm keen to go to a cable robot, is because for the start at least, unless I want like super, super high throws, which I will eventually, but baby steps. Yeah, definitely at least starting out, the equivalent of the platform will be able to move fast enough to throw the ball just by itself. It won't even need like the hand multiplier thing. And that massively simplifies the inverse kinematics to go from desired position to leg lengths to get it there. Like I have to do that step now as well as a bunch of other stuff that's like even like a lot more complicated. So I think cable robot will be so much easier. Anyway, what we're doing, changing the throw height to be super high. Let's go 0.5 meter, why not? But the timing's gonna be off. But let's just see what happens, you know? You don't know unless you try it. And I'm gonna increase the speed a bit as well. Let's see what I'm doing. Here, velocity, let's go velocity to 60 and acceleration 150 is a nice good round number. All right, leave that open actually. Oh, wrong one. All right, so turning the robot on and starting ROS. It's home. That was a throw, just getting ready for the, oh shit. I did not mean to click that just then. Oh my god, this is fast. Alright, throw height, 500 milliliters, throw catch, 30. Let's see what happens. Oh, that's... Alright, maybe that speed is a bit too fast. That was interesting. Still useful. Alright, let's end... Oh, no! Oh, fuck. Why? Why you do this? All right. I am in two minds right now. I want to try this one more time. If I have to go through the whole restore config thing again, then I won't do that now because I can't really be bothered to be honest. But that cable got pulled out again. That was interesting. That failed in a very similar way. The same cable that got pulled out before got pulled out this time. And I think the same, maybe that's just coincidence, but I think the same legs that separated from their base magnets also separated this time. strangely. Alright. Thankfully, they didn't really seem to separate from the platform much, which was good, I guess, made it a lot easier. Yeah, anyway, I'm in two minds about what to do at this point, because this robot is just so goddamn clunky. So clunky. It is not very smooth. It's not very it's not very nice, you know? Whatever the right word is for that. Yeah. Part of me definitely really feels pretty good about the cable robot, but it's going to be a lot of time between that working and now, especially because I want to really improve things. If I do when I do change over to a cable robot, I want to use absolute encoders so I don't have to go through any homing sequence at all. I can just turn it on and it knows exactly where it is all the time, which, wow, that is so much nicer. And obviously a cable robot is like completely different. Well, a large part of it is different to this, but it'll be so much simpler. Anyway, let's see how this goes. All right, thank you, Derek. Thank you. Enjoy whatever it is you're going off to. Maybe, all right, let's just try up and down. I'll allow an up and down catch. If it can throw up and receive the ball, I'm kind of like moving my goalposts a little bit, but I don't really care because they're my goalposts, so I can do what I want with them. I can put them where I want. Right, yeah, let's try up and down. I think if this can do up and down, I'll be happy with that. Yeah, so my zooming out a little bit from the specific issues that I'm having at any given time, my goal for this version of Jugglebot is to, hopefully, I would really like to be able to get it to the point where it can do something kind of cool. I don't know, do you guys, if this, I'm very interested to know your input on this whole thought process. But yeah, my thinking is that if I can get this to do something kind of cool, then I can make a normal, proper YouTube video about this, being like, wow, look at this. Like it's, I don't know, it kind of works and it kind of does these things and it's decent at some things, but not terribly great at what it's supposed to do. And then, so make a proper video, have that be published, and then change to cable robot. And so once this, I basically want to push this as far as I can, make a video on it, and then swap to cable robot. And I guess my thinking right now is like, how far do I realistically think that can go? Because a lot of the problems that I'm having right now, I think are related to this hardware being clunky and requiring that hand multiplier thing. I think if I didn't have to have that multiplier, it would be much faster going from where I should be having it to what I need to tell the motors to do. And I think that would be much smoother. I don't know. Do you guys think this is full video worthy yet? Let me know. What do you think? So let's try, yeah, big throw, straight up and down. Assuming that this works. Let's actually, yeah, damage control first. Boots up all right, that's good. Let's launch ROS. And let's see if we can home. That answers that. I think it was just one motor. Obviously now, it may be more. All right, that actually, I need to change so that when it boots up after homing, it's going slow, and then we set the limits super high. Slow move after home. Yeah, all right. I don't really want to have to mess around with the whole restore config nonsense right now. So let's put it back together and then have a debrief, as it were. Get in there, get in there. Yeah, I think as nice as it is having the motors and the encoders in the actuator, I think it is more harmful than it is good. Whereas my earlier design, my first linear actuator video, had the motors off the actuators and the strings were routed through cables, or through like the, whatever it's called, the tubes. And that was nicer. But it also had problems. Everything's got problems. What has happened here? All right. Yeah, okay. I think I'm going to fix this later. Yeah. All right. Well, that was interesting. I guess the hardware is definitely. All right, no. I'm going to fix this, and I want to try throwing just with the Space Mouse. I want to throw with me in command. Screw my code. I'm not a programmer anyway. I don't know how to do that shit. All right, let's fix this and try one more time. Okay. Which motor is being annoying? They all boot up. I'm going to bring the speed right down until we figure out what this problem is. ROS is working. And let's see what doesn't home. All right, what errors have we got? Four, 5, 2, let's just do all of them. I'm just going to assume that they're all cooked. All right, let's do this again. But this time I'm going to be a bit more efficient and just plug in all 3 so I can do all 6 at once without having to plug and unplug if I have enough cables. But I've only got this piddly little one. Yeah, this should work. I think it counts as Jugglebot throwing if I'm the one controlling it. Is that allowed? I'm going to allow it, I think. The robot, as long as the robot is the thing that's physically doing the throwing and the catching, I feel like that counts, right? It's technically correct is still correct. Get in, come on. All right. Ugh. Now we should be able to do all of the motors at once. Well, not at once, but in sequence. Sort of figure out which one's which. 0 access 0 can config. Nope, it's config can. Alright, so O drive 0 is 0 and 1, so let's do that one first. Encoder false. Actually, maybe so I don't forget, I'll do them all to false. And then do them all to true at the very end. False. Cool. I need to like... Is there a... I feel like there is a way to do this as like a batch command. If I made like a Python script to do this, I think that actually could work. Maybe I should. Especially given how often this seems to be necessary. I'll drive 1, axis 1. Motor. Drive 1, axis 0 motor. Drive 1, axis 0 encoder. Cool. And now drive 2. Axis 0 encoder. Axis 0 motor. Axis 0, axis 1 motor. Oh, yeah, I really should make a Python script to do this. Especially because I am probably going to miss one. Especially the fucking lag! My god, that's annoying. Alright. Boom, 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 boom. Cool, that looks good to me. So now we can do O drive 0, axis 0, requested state 3. And that should be that one. Boom. And down. O drive 0, axis 1. Cool. You've missed a lot of, I don't know how to describe what you've missed. We've had many attempts, no successes yet. At this point, I am resetting everything and I'm going to try throw in a catch with the space mouse. I will need to go back and review this footage I should have actually been recording this. Maybe I'll record it now as well, so that I have a local copy. But I need to go back and like review what's going to be going on, because I've been like half watching it on my monitor and half watching it on the actual robot when it's been juggling, and so I've missed some things as well. But suffice to say, it's shut itself a few times, but not fatally. So yes, exactly. So we want O drive 1, but I actually don't know which one this is yet. So O drive 1, config, can. My god, I can't type. That's 0. Need a dot in there. What? I don't know if that was just me, but that really freaked out just then. O drive 0. No, O drive 1. Axis 0. Config, can node ID. This is 4, I'm glad I checked that. And actually I should write this down. So, O drive 0 is 0 and 1. O drive 1. The reason why I need to check this is because I will need to set the CAN node IDs to be correct once I'm finished with this, so they are actually lining up to the correct motors. And the reason why I don't know what they are is because once I've plugged in all 3 of them at once, it's just a matter of like which one connects to the Jetson first. Gets 0, the next one gets 1, the next one gets 2. And so I need to check what they actually are. So O drive 1 is 4 and 5, so that should mean that O drive 2 should be 2 and 3. Oh my god. Yes, nice. Okay. So we want to do O drive 1, axis 0, state 3. This should be 4, which is this one. Nope, this one. But that didn't run. Why did that not run? Getting an unknown phase estimate error. Let's just clear that. Get rid of that. Try again. Yeah. Oh, nope, nope, nope. That was weird. Let's try one more time. Cool. Okay. Just before it just kept extending. It didn't stop. Don't know why. O drive 1, axis 1. It's this one. All right, one more O drive. So 2 more motors. O drive 2, axis 1. Should be motor 3. Pretty sure it's this one. Yep. And one more. That's what I just did. Why are you not going? Same error, unknown phase estimate. Let's just clear that. And try again. Okay, so they should all be good. I just realized I didn't restore the config on them. Let's see if this works. Hopefully we don't need that step. But we do need to save these as being pre-calibrated. This is O drive 2, axis 1, encoder. O drive 2, axis 1, motor. Overdrive 2 axis 0 motor. Overdrive 2 axis 0 encoder. That's overdrive 2 done. Overdrive 1 axis 0 encoder. Overdrive 1 axis 0. Motor. That's axis 0 done. Axis 1 motor. Encoder. So that's 1111. Cool. Overdrive 0. Axis 1 encoder. Axis 1. Motor, axis 0 motor, axis 0 encoder. Alright, is the pattern correct? 2 axis encoder, 2 axis 1 motor, 0 motors. This is drive 1, 1, 1. That looks good. That looks good. Alright. So I can save them. Overdrive 0. Save. And we should be seeing them move a little bit. So now I can do overdrive 1. Save. And just because it doesn't know what it's doing, I'm just going to be here just in case it falls apart. And the last one. It's a bit of a weird movement then. I'm just going to check the errors. No, we're good. Alright, okay, I think we're good. Let me put the lids back on the O drives. Alright. Now let's see if I can juggle with the space mouse control. And I'm going to count this as a throw. Alright. Let's turn the robot off. Turn it back on. That seems right. Start ROS. Refresh the GUI. And come on, that's home. Nope. That guy's not happy. He's shaking. He's shaking. That's how unhappy he is. Why are you shaking? Stop that. Alright. I'm just going to run through the restore config thing on just that one. Because it looks like the other ones are fine. But yeah, if anyone has any experience with O drives and they have any idea at all why I would need to restore the config after things ship themselves, I would love to know, because I don't currently, and it's kind of annoying. So let's go O drive. Tool, make sure I'm only connected to 1, yes. And that is the one that had the shaky motor before. So, what do we want to do? O drive, tool, restore, config, O drive, config.json. Cool. And now we need to do the whole thing that we just did then. But one more time. Hopefully this will be the last time, hopefully. Yeah, welcome to my life. So this is overdrive 0. V0. Axis 0 motor. Axis 1 motor. Axis 1 encoder. And now we can move them, and I just want to double check what the CAN IDs are because I will need to reset these. Oh no, they've already been reset. What should they be? 4 and 5. So actually I'll do those now in case I forget. Overdrive 0. 0. Axis 0. CAN, no, config. So this is currently 0, should be. Yeah, but I want it to be 4. And then I want this one to be 5. Alright, so they're set. We've put all the pre-calibrated to false. Now we can run the index search. Axis 0, requested state 3. Should be this one. I feel like the motor's making a bit of a different sound than what it did before, but I'm just going to pretend that that isn't happening. Axis 1, so you can watch what's going on. Okay, and now we can set them all to true. Come on. Axis 1 encoder, axis 1 motor, axis 0 motor, axis 0 encoder. Alright. Save, and we should see those two motors rise a bit. Yeah, a little bit. Cool. Okay. I think we're good. But I have been known to say that before. Let's turn it off, just for good measure. Turn it back on. I don't like that when it boots, it can sometimes boot in such a way that it twists itself around as it just did, and then sometimes if it twists far enough, it just kind of collapses. Thankfully it didn't collapse that time. Alright, run ROS. And our speeds are super low again still, so it should be very slow, but I just want to make sure that everything's working. So it's home. Cool. We're alive. Space mouse. Yes. Nothing is broken so far. Alright. Cool. So let's end. Down you go. And let's try it again super fast with me controlling it. I want this throw. Alright, so I'm doing 50 velocity limit and 100 acceleration limit, which I'm pretty sure is what I did before. Got to turn the robot off because I haven't done my code properly. Turn it back on. That's alright. Restart ROS, restart the GUI. And home. I just want to be here because when it goes up, it's probably going to go up quite fast, and there's a possibility that something will go weird. Nope, cool, we're good. Alright, space mouse control. There's a throw! Alright, I need to orient myself so that it makes sense for me. Which direction is which? It's kind of annoying that like I'm right-handed, but because I always use the space mouse in my left hand, I can't use it in my right hand. And I feel like my right hand will be more precise. Alright, cool. I'm oriented. Ah, that's so annoying. I'm going to be facing away from it. That's alright. My god, it's so jittery. So let's... Actually, I want to change one more thing before we try this. I just want to make sure I don't want any of this motion, like your motions. I don't need them. They're a waste of space, you know? So I'm just going to change the code so the space mouse does not create those movements. Your multiplier, 0. Don't want any your, thank you very much. Alright, turn everything off. Okay. Yeah. Alright, I kind of feel like a lower acceleration actually might be good because that was super jittery. Let's try 70 but a higher velocity. Let's try 60 velocity. Maybe 55. Because I was getting some overspeed errors before. Alright, let's give it a go. Turning everything on. And space mouse. Yeah, it's very sensitive in the wrong ways. Oh, the string's fallen out. That probably doesn't help. So we just need to go like... That's it. Let's go down. Ah! That landed directly on top of the O drive box, and I am glad I have the box on top. This feels too slow still. This feels too slow. It's so fast side to side, but up and down, it's just so slow. Probably doesn't help that these are like the heaviest, actually yeah, maybe I'll change that. These are the heaviest juggling balls I own. So just give me 1 sec, I'm gonna grab the other ones. This is live, by the way. Alright, my freshly cleaned actual juggling balls now. Hopefully we'll do less damage if they land on anything. Oh my god, it's so sensitive side to side. No, it's too slow. We need to go faster. Oh fuck! Shit. Alright, I'm calling it. That's that. I'll fix this up again. I may as well do it now. Oh! All my bellows are breaking. They were so nice. I loved them. That's the wrong one. Oh, what is it stuck on? Snap, 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 snap. I'm pretty impressed with these strings. You may have noticed, I think I mentioned this a little while ago, but I've changed the strings. I was using Kevlar, and now I'm using ultra high molecular weight polyethylene. And these strings are bomber. They should be able to hold me. And they're like less than 1 millimeter diameter. All right, I have a feeling I'm gonna have to go through all that restore config bullshit again. And I don't want to do that right now. So, what have we learned? It needs to be faster. It needs to be less clunky. It needs to be better. Yeah, I think I'm going to have a think about this, see how I feel, but I have a feeling I might not push this version of Jugglebot too much further. I think I need to go to a cable robot. I think that will fix a lot of my problems. But this could be one of those things where like the people who are married think that having a kid will fix all their problems. So maybe I'm just kind of like postponing the real issue. But I really do have that feeling. So just to explicate my thoughts, what's happening right now is that I'll show you things in the simulation. If you just give me a sec to change something, and then we'll have to wait a sec while it's going. Yeah, things are too slow. So the process of going from where we want the hand to be to commanding the motors to move to that position takes about 1/3 of a second, and that's in the simulation as well. I haven't actually timed anything on the actual robot before because this is the first time that I've tried this. So that lag is probably even greater between where I want the hand to be and where the motors actually are. And that's not good. I want that time delta to be as small as possible, because once we start adding more balls, I'm expecting to need to rely on some sort of feedback on where the ball actually is to make catches properly, and that feedback is only going to be useful if the robot can actually move around in real time. Because if the robot can't move around in real time, then I'll be updating the position of the ball, but it'll be too late because the ball will already be past catching point or whatever. But it'll be less useful if there's more of a lag. Yeah, so I want that time to be as small as possible, and I have a lot of code, a lot of like inverse kinematics that's required for this like hand multiplier business, and that wouldn't need to be there for cable robots. So that aspect will be faster. I believe the robot should be much more mechanically simple. This is not mechanically simple whatsoever. Yeah, changing to absolute encoders is going to be good. Yeah. It's just a matter of like what do I put in the YouTube video for this Jugglebot, because I want to make one for this just to be like, this is where I'm up to, this is how the robot's gone, this is why I'm changing. But I need to have a think about what can actually go in that video. I was really hoping that I could have a throw, and to be honest, I'll keep playing around with this like throughout next week and see if I can tune it to get it to work. I think I might just have to do the dirty and just like pre-calculate in advance just like a giant lookup table of where the motors need to be, and it will just grab those positions super fast. Yeah, I think I'll do that. And that should work. The robot can move very, very quickly in some situations. It's just if it does those movements in the wrong way, then it falls apart, and then we have to go through that whole recalibration nonsense. Yeah. All right. I think if I do the dirty and have it just be blindly following a path that I've pre-calculated, I think it should be able to throw, and I think that'll be sexy enough for an actual video. All right. That'll be my next week. Solved. Done. I need to, I don't know, sit down and do something else for a bit. This is driving me mad. All right, well, thank you everyone for watching. This has definitely been, I'm pretty sure it's been the longest live stream I've ever done. And yeah, I appreciate you all sitting in. I regret that it wasn't, sorry if that was loud, I regret that it wasn't as successful as it may have been, but you know, that's robotics. Robots don't work. They don't like doing what you tell them to do. They like breaking, because that's what robots do best. Yeah, anyway, good luck with everything that you are doing. I hope that everything's going well for you all. Have a good weekend, and I'll see you next week. Hopefully with some progress. I'm sure that there will be progress of some sort. Well, we're just unsure of what that will look like right now. Yeah, till then, have a good one.